All right, here we go. So, of course, this topic that we're hitting is data structures, and this is really getting towards a big part of, really we've been working towards this the whole semester, and it leads us into the core concept of 162. Now, 162, we learn about a lot of different data structures and how we can use it, et cetera, different problems and whatnot. So there's more to it than just data structures, but data structures are a big, important tool. And last time, we started by saying, okay, what are we going to do? Well, I'm going to make a course data structure. It's going to be a chunk of code that's going to manage student objects where I can keep track of what students are in what course, let's say. All right? Yeah, it's a bit of a contrived example, but whatever, it'll serve its purpose. All right? So we started with a student object, a very simple object. All we have here is class student. The initializer constructor, it's just assigning the attributes. We've got an equality check. And for simplicity, and perhaps there's a good functional reason, for two student objects to be considered equal, we're going to check if their student numbers are the same. Their names might not match, but as long as their student numbers are the same, they're considered equal. And maybe they change their name, right? And then some repr. And like last time I said, sometimes, if we don't have an idea in mind for what we want our string representation of our object to look like, we use that class name parenthesis attributes. But in this particular example, you'll see I'm not doing that. I'm doing last name, comma, first name, tab, student number. I just want it to be formatted like that. So it's like if I have a group of students and I want to take a step back and say what do I want? We're going to be writing a course data structure, all right? And I'm going to write a repr for that. What do I want that to look like? I'm going to kind of want it to look like a list of the student objects. Last name, first name, student number. Last name, first, and like a table, effectively. I don't want student, parenthesis, attribute, right? I don't want it like that. That's not going to work for me. If it works for you, great, whatever. But remember, we get to invent however we want it. Now, I didn't actually include the unit tests here, but because we did spend some time talking about unit tests, let's look at some unit tests. These are what the unit tests could look like for the student object. They're not in Colab. I just got it here so we can view it. It's kind of hard to see. Let's zoom in. There. All right. So what do we have? Test student first name returns correct first name. Create it and check their first name. You get that back, right? If you remember in lab when we were doing unit tests, when I did these tests, I actually left these blank. Who here remembers why I did that? Why?
You did it because it wasn't necessary for.
Exactly, right? Is it wrong to include? No. But my point was I left it an empty string and who cares? Because I'm testing the first name, I don't actually care. So there was nothing really lost there. But in terms of a design decision, it also really emphasizes, well, what's being tested, right? If this was Bob and then nothing, you're left going it probably has to do with Bob, right? Does it matter? No, it really doesn't matter functionally speaking. But in terms of making your code as expressive based on what you need it to do as possible, that was the argument. Student last name returns correct last name. You might also start to see wow, a lot of these feel like it's the same tests, just every time we're testing these objects, the tests are starting to look very similar. Yep, yeah, there's a pattern to it, right? And that's a good thing to recognize because that's usually what you want to do. Yeah, okay, test student, student number returns correct student number. Cool. Test equals on students with same student number returns true. All right, there we go. Student A student, blah, 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 blah. B student, blah, 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 blah. The point here is their student numbers are the same. And then we say assert true. There we go. Now, you might remember, and maybe I shouldn't have written it like this, but you may also remember that in the lab, I didn't do assert true on my equality tests. What did I do? Who remembers? What did I say? Yeah, in lab, yeah. Who remembers what I did instead? It's fine if you don't. I'll just say it. Instead, what I did was there is an assert equal. Whoop. Oh my goodness, what did I do? There's an assert equal. Assert equal will go and use that object's equals method. So assert true, student A equals student B, would be the same as assert equal like student A comma student B. It would be functionally equivalent. But there's an argument to say like, well, you know, use the correct assert method. It's a little nicer, you know? Like, okay, yeah, cool. But there's nothing wrong here. Test equal on student with different student numbers return false. All right, there we go. Cool, they're different student numbers. And it should, maybe it's obvious to you, like, okay, well, first of all, yeah, they have the same first name and last name, A name, right? But the student numbers are unequal, so therefore this should not be equal, right? You'll also notice, like, the dummy values for this, it's not a bad idea when writing tests to make the dummy values really obvious that they're dummy values, because it's the point of the tests. Like, again, you want the code and like the values and everything to be as obvious and clear as possible, like what's being tested and what matters and what not. Test equal on student and string returns false. Cool, right? Now, why did my string look like this? It didn't matter. You'll notice that this string looks kind of like what the repr would create for a student that looks like that. It didn't need to be. I could have made it like the string like hello world, whatever. But the point is, they're not equal, right? A string and a student object, not equal. We could play this game forever where, well, what about a student object and a Boolean? Are they equal? What about a student object and a shoe object? Are they equal? If it works as expected for unmatching types, you should be pretty confident that it's going to work the same way for unmatching types. The code would have to be rather absurdly written to not work for strings, but to somehow magically work for floats, you know? So, you know, use your judgment on that case. And remember, writing tests, kind of an art instead of a science. And then test repr, arbitrary student returns correct string, Bob Smith, 1, 2, 3, 5, 7, 8, 9, and this is what we should get. Smith, comma, Bob, tab, 1, 2, 3, 5, 7, 8, 9, then whatever the string representation of the student is. Cool. Any questions about the unit tests for that class? Everyone's happy? All right. Now, all right, cool. Now it comes to like, okay, let's make the actual data structure. I want to make a course class. It's going to be a collection of student objects. At least that's what the point is. Effectively, this class is going to be like a wrapper for a list. It's just a list, okay? So we're hijacking the list, and the list is going to do all of like the work for us. But because the point of this object, the point of this class, oh, that's kind of class, course. This course object is to manage students in the spirit of representing a class, a course, right? Do you see the problem? Class, course, yeah, right? Just follow me, please. So like a list could work, but I want to like kind of like create an object that is designed to kind of like interface with the list in a very specific way for my needs. So you might feel like, well, you're just hijacking a list. Why not just use a list? You're right, but that's kind of the point, is I kind of want to like hide the what from the how. Remember we talked about this before? What is it? It is an object that's going to represent a course that's just going to hold a bunch of students. How is it going to do that? With a list. But the what and how, obviously they're connected because the how needs to implement the what. But I really don't care. Like if all I really care about is the what can I do with this class? I really don't care how it works. In the same way that You've all used a list, but did you know how it worked under the hood? No. For all you know, it's a bunch of fairy dust, right? It doesn't matter. But it does what it's supposed to do. How it does it? Sure, it's interesting. That's like what we talk about next semester. That's what we learn about all next semester, right? But in terms of the spirit of programming and what we're doing here, the what is what's important. So all this is to say, yeah, I get that you might feel like it's just a list. We're just hijacking. Yes, but we are really trying to create this like interface almost, this course class that helps interface the what and the how. So that's where we're going to go. Any questions about that? All right. So what is this class going to have? All right. Well, it's going to be a students stored in a list. Yeah. But the course is going to control access to the list of students. All right. And it's going to have a couple of methods and attributes. A method, we're going to want a method to add students to the list. It's probably just going to use the append method. A student to remove students from a list. I don't know how we're going to do that, but we'll figure it out. A method to get the size of the course, like the number of students enrolled. A method to check if a given student exists in a course. Sounds like a linear search, right? We're going to want a repr. We could write in equals, I suppose, but equals is going to be tricky for courses. Whenever you have like a data structure, like a collection, defining equality for collections is actually kind of tricky. You could do it, but you have to be very careful. What does it mean for two courses to be equal? The same set of students? Do the students need to be in the same order in the list? The implementation questions we have to think about. But for our purposes, we're not going to worry about equals for our data structure, which is actually not that uncommon. But we will want a repr, which we kind of talked about before. Here's how we're going to start it. Looks like our class has two attributes. But you'll notice that the initializer, the constructor, only takes one parameter, the course name. Okay? So it's going to have when we create a course, we'll give it a name, like CSCI 161, for example. But there's another attribute called students. Actually, it's called underscore students. What's up with that? Just give me a moment. And it's going to be equal to an empty list. What this value got set to had nothing to do with the parameter list. The parameter list being all the elements here and there. Okay? Perfect. And on that, I think we'll end. That's not a joke. All right.